Back to the Type tab. In the Standard Fixed Geometry and Fixed Geometry, in the blue box you can select the face or edge or vertex to fix it, and in Advanced Fixtures. The first is Symmetry, suitable for mirrored components that's shown in the figure. In the blue box you can select the fixed face or edge or vertex. In pink box you can select a reference, planar face or edge. And below there are 3 translation directions based on the reference. Back to the Type tab. Click on the Force type and keep the normal radio button. Move the mouse cursor on the various locations of components. For example, flat face, cylindrical face, cylindrical edge, on a edge, on vertex. And also you can see the changes on the purple arrows. Direction of arrows always is normal to the selected items. Value is 1200 Newton. OK. See the animated stress action on the C components based on the determined loads and forces. See it and finish the command. Again, right-click on the stress in the design tree and select the section clipping. You can see the result in the section view. Also, you can change your current standard work plane to see better the results. As you see, the pin is simulated in blue color. OK, then in the fixture command, make this 2 flat faces of Bosch components to fixed. And then OK the command. And finally, simulate a torque for this assembly complex. You can see the von Mises stress in the sections of component. Then cancel the command. Double-click on displacement to activate. Right-click on the result and select the define factor of safety plot. Select the max von Mises stress. And OK the command. Take the No Translation checkbox. OK the command. Again in the blue box. Select this 3 cylindrical faces of smaller holes. You can see the simulation result animation. And simultaneously see the von Mises stress in the color column. OK. And select frequency. Now in the design tree, right-click on fixture and select the fixed geometry command.
Right-click on Thermal 1 and select Chart option. See the maximum and minimum plot. Also, you can change the type of temperature showing. Right-click on Thermal 1 and edit definition. Again in the simulation type, select the fatigue and OK the command. Check the tabs in bottom of graphic area. Study 1 is static analysis. And Study 2 is fatigue analysis. And frequency, Hertz. Remember this value. And OK. Again, right-click on Frequency 1 in bottom of graphic area and select Create New Simulation Study. And now select the Design Study. That's on the previous version of SolidWorks, it was called Optimization. And OK the command. In the Table View tab, tick the Optimization checkbox. And in the Variables, click on Add Parameter. In the Specify, you can choose your test type, drop or impact. And also right-click on Stress 2 and select Animation. You can see the falling down simulation. We have an assembly that's created from 4 separated components. This is ball valve skin. You can select your fluid material. In the liquid, select water. Click on Add icon. Flow type equals laminar only. Next step is wall conditions. Keep the default and click Next. And finish. Right-click on Boundary Condition. And this results helps the designers to enhance high-pressure sections of own products. Click on its command. And choose Rotary Motor. In the Components/Direction blue box, select this cylindrical face of this component. If needed, click on Reverse Direction and choose the best situation. You can test it in other parameters yourself.